game devs. In this video, we're going to cover creating a point-and-click adventure walk-around interface, kind of like the old Secret of Monkey Island, but we're going to use 3D, and we're going to also learn about... And so the second thing that we're going to do is we're going to create a little quest system. So the second thing we're going to do is create a little inventory quest system so that we can open up some doors. So we're going to have a little collectible, and you're going to be able to go touch it, and then a door is going to react conditionally to whether or not you have the key. So we're going to use this for that. So the first thing that we're going to do is we're going to create a new scene. We're going to save this scene as point and click. And we're going to create a just something to click on and to look at. So let's see where our scene is. Right now we're in 2D mode. Let's get out of that. And I can't seem to find my camera. Oh, there it is. There we are. So I'm just gonna, for the most part, leave the scene just basic. But what we'll do is we'll bring in the baker's house. So which I downloaded, prefabs, baker house. All right, and let's just position that somewhere over here. And let's give it an angle so that we can kind of look at a corner, give some interesting geometry. And then I'm going to just open Pro Builder really quick, and we're going to create just like a floor and a backdrop for the area, but it's just kind of quicker. Let's go to object mode, move this down, face. Oh, looks like Baker's house is slightly above. All right. Grab faces. Maybe we'll pull this out. Oops. And we're going to give it some geometry back here as well, just to pull this out, and then give it maybe a wall. All right. All right. So I think that's good enough. So we just have the scene, and there's some things that we can click on that'll be interesting. We'll modify this in a little bit to maybe be a little bit at a higher angle, but for now, I just want to get the raycasting part done. So now that we've got this here, let's create ourselves a mouse click script. Oh, first, let's save, Control S. And then let's create in our scripts folder a C# script called set position. All right. Okay, so we're going to keep the update function, but we're going to obliterate everything else. So now that we have our set position function, I deleted the start, and I'm just going to leave the update. And we are going to create a couple things up top here. Let's type in ray, my ray. So we want to create a ray. Raycast hit. Hit. The thing that we hit with the Raycast. and then public game object, object to instantiate, semicolon. So we're gonna create a little round sphere, and we're gonna create and then when your mouse clicks on something, it's gonna create one of those. It's not gonna be very efficient. But this is just for demonstration purposes. So now we've got void update. We have to do something. We have to cast the ray. So my ray camera dot main. So what we're asking screen point. So camera dot main screen point to ray input dot mouse position. What we have here is camera. So we're going to access the camera in this the scene, and then we're going to say we're going to find the camera in the scene. We're going to access it, and we're going to fire a laser beam straight through the screen. And so if you think about the three-dimensional space in your computer, if you think of those as a real space, and that your window is merely a window into that world, how do you know like which object that you clicked in the background? How do you figure that out? So what we do is we fire a raycast and from the screen position. So we do this in a lot of different ways. If you've taken a look at my Corgi video, there is that entire system is based off of raycasts, where the character is constantly like touching and feeling, shooting raycasts out in order to know what's around them, because it's not a physics-based engine, which is the original way we used to do things. Raycasts can be really efficient as well. So a lot of times when you have video games, you don't actually shoot physics objects that move through the scene. You actually just use raycasts and hit, and you create artwork around the event of bullets or whatever. But it's all math behind the scenes, and it's actually just invisible laser beams being shot back and forth. It can make your code much more efficient than like running physics on everything. So we've got our raycast. Now that we have that, we're going to say if physics, blah, P for physics, dot raycast, my ray, out, hit. And then we're going to nest something in here. If input dot get mouse button down 0 for the left click. Then instantiate object to instantiate, comma, hit dot point, comma, quaternion dot identity. So quaternions doesn't really make too much sense if you look up the Wikipedia article, but they're used for rotation. They represent the pitch, yaw, roll, and other things of that nature. So this is part of the transform. If you don't put this in, it's going to think, so this hit point is a vector 3, but it's going to say, hey, you can't give a vector 3 as a transform. So what that means is this vector 3 is three pieces of information, right? X, Y, and Z coordinates. So you need to add the quaternion, which is the pitch, yaw, roll, because all things in a transform have position and rotation here. So you have to get both of those lines in order to create it correctly. The quaternions generally are really hard to understand, but it's just math. So from here, let's go in here. Let's go to our scripts, and then I'm gonna set position I'm going to put it in the main camera for now. And then the object to instantiate, I'm going to create, or I've created a little red sphere. I've added the red texture. I'm just going to drag, this onto my main camera into the object to instantiate. So if we play now, we should be able to click and look at that. Poof. Now, look at this. So this does not have a collision layer, so it's not returning a collider. We can actually add objects everywhere on the floor. Really important to note is, the Baker house actually does not have any colliders on it. So we're just going to add a new collider. Mesh collider, and then we're going to add the mesh into, oh, I already grabbed it automatically. So hopefully we can click. There we go. So we just needed to use the mesh collider here. And now we can click all over. Okay, it's like got warts or something. And then, it also, you can kind of see this here. You can also stack up circles. Oh no, it's coming for you. So from here we can have all sorts of different options. But this is just the first part. So now that we have this that is clickable, we should do something actually important later on, right? All right, so that was just, for demonstration purposes. We're going to adjust our code a little bit. All right, that was just demonstration purposes. We're going to adjust our code a little bit. We're going to go to the main camera, and let's increase my scene view. Let's make like more of a angled or top down. Oops. Raise it up. And then we'll go. All right. So we're gonna move the camera up and a little bit angled. I made this big wall here, but I'm actually gonna delete it just for this next part. Face. And I'm just gonna put a floor down. Just a big plane. Object mode. All right. Good. So now that we've done this with this in the update function, we're actually going to pull it out of we're going to change this from an update function to void on mouse down. So on mouse down is a command that we can trigger. We've got my Raycast. So we're declaring this here. We're putting it here. We can keep that there. And then instead of if physics Raycast hit, we're just going to say physics.raycast semicolon. So we're going to cast it. And then bring this back. You always want to keep your code aligned when you can. makes it really easy to maneuver to look around. It'll do it for you, but sometimes if you're adjusting things, so if hit dot collider dot game object equals game object. So if the hit of the collider is the object that I am, if I am clicking on the thing the script is on, and then we're going to say vector 3 new target equals hit dot point plus new vector 3 0 0.5 f float 0 semicolon. And we're going to need to declare something. We actually don't need this object to instantiate anymore. So instead of having that, we're going to create public, and we're going to call this a properties and coroutines. Coroutine script. All right. So we actually don't have this yet, so it's going to throw us an error. So why don't we make it? In our scripts folder, create new C# script. Oops. Let's hold it to open the project. Go to Unity. Let's create C# script. Let's call it properties and coroutines. All right. So now that the namespace is there, should be able to go back into set position. And yeah, see, now it's green. Now it's actually a class. So what is this? Line 16 here. Oh, whoops. I left a parenthesis. Oh, in. I left a parenthesis in. All right. So now that we have this, which we're going to add it to the plane so that we don't forget about it. And then we have this coroutine script. All right. So coroutines. All right. So coroutines are really, really important in video game development, just like time.delta time, which is all about how the computer clock runs. We also have the ability to run code, and then we can have it sequence itself so that it can have waits and pauses, all the good stuff that you really thought, or that kind of comes naturally. But it's actually kind of hard to express in programming. But it comes naturally as like the thing that you want to do is you want to do time-based stuff. And so this can be really helpful for like when you want something to move across the screen without any animation. We can move stuff around the screen, and it's also very efficient in terms of code. It is much more efficient than, for instance, the physics system. So now that we've got properties and coroutines, we're going to start declaring some variables in here. We've deleted all the update and start stuff. And then let's type in public float smoothing equals 10f for float. And then we're going to do something that we haven't done before. You might see this in, you'll see this in other tutorials. Target, and then we're going to actually use open parenthesis or open brace, close brace. We're going to say get return target. Nope, lowercase t. Set target. Oops. It keeps, let me fix this. We're going to go to public float. Go right underneath here. Public, or no, sorry, not public. Private. Vector 3. Lowercase target t. Okay, that'll fix that. Target equals value. Stop coroutine. Movement. Capital M, and we're gonna add that in a second. Start coroutine movement target. So we're going to use this to control the information on mouse clicking. We're going to figure out what the target is, and then we are going to set the new the coroutine to go to the target, and we're going to stop any original one, right? Because we don't want to have two competing coroutine commands that are telling it to do different stuff. All right, go out of here. So now that we have this information, getting and setting, you'll see this in a lot of different areas. It allows you to control your information a lot more. Sometimes if you want it to be read only, you could just get or set only. But in this case, we want to have the control to do both. So we're going to use get and set. Now, now usually when we type in stuff, we say like void, right? Blah, 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 blah. We're not going to do that this time. In fact, what we're going to do is we're going to type in I enumerator movement, which didn't exist, but now does, right here. So we're going to call this, and you can think of the I enumerator like when you're declaring a function. And then vector 3 target. So when we want to fire up a coroutine, we can do it here. Or this is the coroutine we're firing up. And what it will do is while vector 3 dot distance of transform dot position. Now, so this is of the thing that it's comma target transform position comma target, and then outside the parenthesis greater than 0.05 f. So while while the distance of the object is greater than the target, which is when we do mouse, when we grab the mouse, right? Set position, right? Target. So this is where it kind of crosses over. While blah, 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 open brace, close brace, transform. Oop, that's not it at all. Transform dot position equals vector 3 dot lerp. Lerp is a mathematical function that allows you to linearly interpolates, right, between 2 points. So there needs to be a point A and a point B and a time on which it is going to be moving. So lerp is a really cool function. You'll see that a lot, but it doesn't really make sense if you didn't take it apart. But it's just between 2 points, it's something moving. Transform dot position target smoothing times time dot delta time. All right, so over the time that's doing it, yield return null, and this is going to be, oops, I misspelled yield. So yield return null. Go out here and let's just use our same prefab, my mouse click character. It'll be a character now. it's been upgraded. So my script is, oops, not there, script properties and coroutines. We're going to drag this onto my mouse click. So the set position script is actually on the wrong thing. Remove that from the main camera. That's not where we want it. We want it to be on. And then we're going to go plane and make sure that the set position script is here and that, oh, we need a coroutine. So we're going to drag my mouse click, coroutine script. And then that way that is on the environment because we only want the position of the floor, right? We don't actually want to have the position of this thing over here. Click script off of the main camera. We've got properties and coroutines on my mouse click object. And on the plane, we have set position, coroutine script, my mouse click, so that it's connected that this object is this plane. Because we don't really want to have like everything, right? We just want to have the one plane for it to walk on so that the character can move around. So now that we have that, we actually have to modify the script just a teensy bit more. So we actually have to tell the target, right? The coroutine script up here, which is not so public properties and coroutine script, right? We need to get that somehow. And we need to tell it what the target is. So coroutine, I'll never be able to spell that correctly. Coroutine script dot target equals new target. Oops. So this thing here, this is the new target. Now this 0.0 or 0.5 is an offset so that it doesn't go into the ground. If this was 0, it would, go straight into the ground. But we want it to actually kind of float. So we're going to save that. We're going to hit play. And hopefully, whoops, there we go. Now we have a little thing that clicks around. This is going to be our character, right? Oh, and we are hidden in there, which is, it's okay. And also, when I can't click right here on the plane unless I get really close, so there might be some bug fixes, but that's because there's a collider on that, right? So just like if we wanted to run into stuff, but we didn't want to be able to click on this plane, this will stop the raycast from colliding with the object, kind of like, so that way if you wanted to move the camera around, you could also move it around. And then it'll go through still because this is programmatic and this is not physics-based, right? So anyway, so that allows you to have a bit of a coroutine to move stuff around. Let's look at this just a little bit more, give a little bit more information because, we've done a lot of coroutine, but I just really information, but we didn't really put any debug lines in and just so we can demonstrate this. So let's say we wanted to do a little bit more. Oops. Let's go to our properties and coroutines, and then let's go down to the IEnumerator, and then we have yield return null. So while we're inside of this, we can still, this is to return false. So we've got yield return null, but we have some other yields we could do. Yield return new, wait, oops. We've got wait for end of frame, wait for fixed update, wait for seconds, wait until. So lots of different functions in there. We're just going to say wait for seconds. 3F, oops, for float. So wait 3 seconds, print 3 seconds have passed. So for this, it'll go through all of this top to bottom. It'll do all the while loop, and then it'll return, and then it'll play after 3 seconds. So go to our console. 3. Boop. There you go. 1, 2, 3. Boop. There. All right. So this is how you control time. Now that we're controlling time, let's try to think of a puzzle, right? Like maybe you want to you want to go collect an object, and you want to make sure that you have a couple of them. Maybe it's like a crafting system, or it could be really anything. In this case, we're just going to use keys and doors because that seems to be that's the easiest thing to do. So let's talk about lists. Um, so let's talk about lists that we can access, increase, and decrease. It's a big table of information, and that information can be any kind of information. It can be a game object, it can be a position, it can be stuff. So if if you ever played like a RPG game where you had an inventory and you pressed I for inventory, and then there's all these little square slots, and you can put any kind of game objects you want in there. Maybe some of them have different properties or whatever. So we're going to kind of think about that. We're going to access a list. We're going to play around with it. We're going to add and subtract to it because it's just like a little database of information. Now, you might come across arrays. Arrays are a simplified version of that, which are not usable during real-time games. So you need to, when you write an array, you'll see a lot of the same functionality here, but lists are where it's at in terms of being able to add them on the fly. So it can be really helpful for keeping information and that kind of thing. A lot of video games will, like Zork the Grand Inquisitor and that kind of stuff, all those old text-based adventure games, a lot of those have a lot of those are based off of a big array, a two-dimensional array, which is a grid, right? X and Y. A one-dimensional array is merely a series of boxes that are containers that that will hold information that is just in a big list. So, it can be either or. You can also have like three-dimensional stuff, but that gets into like, why would you need that? You might need it maybe in like a voxel game. Voxels are actually a really good example of that, where they auto-generate a bunch of information. I'm sure lists have something to do with it. So any like Minecraft or anything like that, where it auto generates, that's a three-dimensional array of game objects that get generated. And it allows you to kind of figure out, it allows you to do just a ton of stuff. So what we're going to do is we're going to go to our project and go to our scripts, and we are going to create a C# script. We're going to call it player inventory. So we're going to go into our scripts. We're going to create, let's just make the keys first and make it so that we can touch them and then they destroy. So let's create 3 different kinds of objects. Game object, 3D, a sphere. Oops, our player is a sphere. Let's create 3D object, capsule. Let's create cylinder. Then let's create, oops, not an empty. A cube. All right, so we've got cubes, cylinders, and capsules. Those are different keys. Let's create some materials. There, create material, blue, blue. Now, code wheel is really helpful, but just as FYI, some people are red-green colorblind, so red and blue are better paired colors. We've got, oops, this is a new behavior script. We're going to create a material purple. The best way to do this is just to mess around with where the dot position is if you're going to be using opposite colors, so red and green, blue and yellow. These are difficult things for people to see. So if you're going to use those colors, it's fine. Just make sure that you mess around with the saturation and everything so that it is different for like a the black values are different so that it is visible to people. Rename this purple. And then create another material. Let's see. This one will be greenish. Oh. Create green. All right. So green, purple cubes, and blue capsules. All right. So we're going to have all these three things. All right. So now that we have all those, we are, let's make these named something. So rename blue key, or maybe key blue, so that we can get naming. Naming conventions can be important. So if we're doing a lot of objects that are the same type, key green. It often sorts better if you throw stuff in like your prefab folder. Key purple. All right. So let's go into our scripts. And we're going to create a new script. And this one is going to be called player inventory. And then drag this onto our my mouse click so that we don't forget. My mouse click being our character. Player. Let's just rename that player. All right. So now that we've got that, let's open up player inventory. So first thing we need to do is we need to declare the list. Oops. First thing we should do, declaring a list. Public list game object keys equals new list game object. Oops, not braces. Open parenthesis, close parenthesis, semicolon. All right. So so what we're going to do here is we are going to collide with a game object. Oh, you know what we should also do? Let's add a tag to each one of these. Tagged, add tag. So this is going to be key. So we want to just tell just so that we can sort and not touch like this thing later on. So we'll go to tags and then we'll set them as key tags. That way we can we know that we're only touching that. It'll help us out later on. So now that we've done that, void. Here, we're going to delete the update and start again. Void on collision enter. As we as we want to touch the other objects, and we want to understand when we touch them, and that collision is other. If collision dot game object dot tag equals key. Oops. Then do a thing. So if it's a key, we can destroy game object. Oops. Dot game object. So first, let's just see if we can collide with these things, make sure that they destroy. And let's click. Oh, hey, look, it looks like it does not. So the reason for that is because we forgot to add a rigid body. So the player here, add component, rigid, oops. Rigid body. And we want to turn gravity off because we need to detect whether it's colliding with stuff, but we need a rigid body to do that. Bam. And when you click, it immediately destroys it. But when you go touch this, it doesn't destroy this house, which is good, right? So now that we've done those things, let's go in here and let's add, before we destroy it. So now that we have this on collision and we want to say on key, collision.gameObject.tag equals key, we want to create add this object that we touch to the keys. Keys.add. Now, if you look at it, dot add clear, add range for each. Lots of different things we can do. We're just going to add right now. Collision. Dot game object, because it is a game object, not a collider. You're not adding colliders. You could just add the colliders of things, for instance. This would be more efficient, but we're just gonna say add the game object. And then we're going to go to our player and we're going to open up keys and see how it says size 0. Size 0 means that there's no objects in the list. But let's go look at that. Oh, it looks like element 0, missing game object. Also, it looks like our sphere is spinning. That's all right. So add 2. So we've got it kind of working, but then it kind of deletes it, and kind of deletes it. So So now that we're gonna now that we can touch and destroy things, we're gonna go back in here and it's actually a public list game object. Let's change this up to the thing that we want to have, which is a list of words in this case. So we're gonna say string. String for letters and words, so stuff like this. And then if collide with key with the key tag, we're gonna say keys dot add, and it's, as you can see, it's looking for a string. So we're gonna say collision dot game object dot name. All right. So now that we've got that, I'm also just going to open up my rigid body and constrain the rotation XYZ because I don't want to have anything going on with that. It's just a small detail. And then we're going to watch our keys list increase, and hopefully it'll add the name of each key. Key green, key purple, key blue. Awesome. So now we have these 3 elements here. Let's create some sort of object that will respond. I'm also going to delete this coroutine bit because we don't really need that anymore. That was just for demonstration. So we got keys.add, and then we destroy them. That seems really awesome for the first part. So let's go through the same system. Let's say gate, right? Let's check to see if there's a gate, or to create a gate, and we're gonna create and we're gonna go into Pro Builder. Pro Builder's got some sweet gates, specifically doors, which are prefabs. New shape. So we want to make a door. And we're going to hit build. Oops, all my windows are stacked up on each other. Apologize. So now that we've got that object, let's create, oops, I was editing it, wrong window. All right. We're going to want some color. Vertex colors. And we've got blue. I'm just going to grab whatever standard. So I took the lower blue, get a green. Oh, that's a little, there. Purple. Yeah. Or fuchsia. Yeah, that looks like that. That's good. So we can close that out. And just for the sense, just for purposes, we'll just, for what we're doing, we're going to just create these doors, and we're going to tag them as doors. So we're just going to compare we're going to look at the list, and we're going to say, hey, do we have these keys in the list? And if we do, then use it on the door, or, delete the door in this case, just because we're going to be pretty quick and simple here. So if collision there, we're just, we can just continue to use this function. If collision, or I'm just going to copy paste it. So now that we have those doors in there, we're going to say if collision and we're just going to do this kind of hard code it with 3 of them. Game object dot name equals purple door. So we're going to go if collision blah 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 purple door, if keys dot contains, and then open parentheses, close parentheses, key purple. Oops, and it's probably door purple. Got that mixed around. So if key contains key purple, then destroy collision game object. So if you have if it has the words key purple, game object blah, and then we also want to subtract the so then we've got to access the list. So we're gonna say keys dot remove key purple. All right. And if I don't have that script, I will be able to, or if I don't have that key in the list, then I shouldn't be able to destroy the door. So we've got a green, and then let's go make sure we're reading our list. So we've got key element, key green. And so nothing happens when I touch that door, and then nothing happens when I touch the purple door other than I bump into it. And then I go collect the purple, key purple, and then bam, I touch the door and the door disappears. And then the element key purple is removed. So that's just a very simple way of accessing a script. If you wanted to, for instance, use multiple keys on a door and then check to make sure that you have enough, there are ways you could store multiple keys on there and then count how many of them are on the list. You can iterate through the list. Using .contains is a kind of lazy way of doing this, but it's going to be okay for now. So that's how you can have coroutines. You can have an inventory system. You can do a lot of different things with lists, but it's really valuable. The really cool thing too is that, like, if you wanted to create a list of enemies, for instance, you could create, you could randomly generate all of those and stick them into a list of enemies. That list of enemies could then be managed so that, for whatever purposes, so you could turn all the AI off or whatever. You can do absolutely anything. It's a really powerful part of the system. That's all I have for you in this video. I will see you in class.